Welcome to Coach Eichner's Math. Today we'll be talking about parallelograms. The very first thing we got to do is we got to talk about what a parallelogram is. But to do that, we have to talk about a few other definitions first. Quadrilateral is the first one we're going to talk about today. It is a closed figure formed by four segments intersecting at their endpoints. This would be an example of a quadrilateral because we have 1, 2, 3, 4 sides. There are several other quadrilaterals I could have drawn, a square, a rectangle, or anything in between. Rhombi, diamonds, kites, they are all considered quadrilaterals. So, specifically talking about parallelograms, a parallelogram is a quadrilateral, which means there will be four sides, in which opposite sides are parallel. So at this time, I'm going to go ahead and mark my opposite sides as parallel. Notice one arrow was a set of parallel sides, and then my double arrow was a separate set of parallel sides. You'll see that quite often in this unit. So make sure you remember that means parallel. Diagonal. A diagonal is a segment joining opposite vertices in a polygon. Well, in a quadrilateral, if I go from one vertice to the other, this right here would be considered a diagonal. There would be a secondary diagonal going from this vertice to this vertice. Right here would be considered a diagonal. It is a segment connecting two non-adjacent endpoints. So, looking at example number 1. The parallelogram at the right has four vertices. What are they? Well, we can say point N, point P, point M, and point Q are our four vertices. So, when we go to name this parallelogram, I would say it is parallelogram. Notice I draw a little parallelogram. N, P, M, Q. Now, order does not matter here as long as I go to an adjacent vertice every time. Notice I went N to P, P to Q, Q to M. N, P, oh, I didn't. So N, P, I should say Q, M. Let me go ahead and switch these. Call it Q, M. It's important we go in that order because later on when they write it down, we're going to make sure that we have that solved. So N goes to M, goes to N, P goes to Q. So we're good to go there. So opposite sides of the parallelogram are parallel. Opposite angles, okay? So opposite angles, angle M and angle P are opposite angles. Opposite angles are congruent. And consecutive angles are supplements. We know this because of our parallel lines, something that we have talked about earlier in the year. Again, congruent means it's same. Supplements means that it adds up to 180 degrees. The diagonals. Okay, the diagonals of my parallelogram are bisectors of each other. What that means is this point where they meet in the middle is the midpoint of both of my diagonals. So N and my midpoint, we'll call it R. NR would be congruent to RQ. MR would be congruent to RP. So, some special things that we know about parallelograms. Flipping over onto the next page, we are going to talk about it in detail. Notice right here, stuff we've already talked about, opposite sides are parallel. I'm going to go ahead and mark my opposite sides parallel. Opposite sides are congruent. So I'm going to go ahead and mark opposite sides are congruent. Opposite angles are congruent. So this angle here would be congruent to this angle here. This angle here would be congruent to this angle here because they're opposite each other. They're non-adjacent. And consecutive angles are supplementary. Remember, supplementary means they add up to 180 degrees. Diagonals bisect each other. So these two pieces must be congruent. And these two pieces must be congruent. Looking down below, we're now going to put those 5 rules to use. Example number 2, complete each statement regarding the parallelogram below. Name the parallelogram. Going to not make our same mistake again as I did last time. I'm going to start here and go D, A, B, C. I'm going to call it parallelogram D, A, B, C. AB would be parallel to segment DC. DA would be parallel to CB. Angle CDA, this angle right here, would be congruent to angle CBA. Make sure that you put your angle sign in there. And DE would be congruent, this piece would be congruent to EB. We're eventually going to get to the point where we start using this to our advantage. So let's look down at example number 3. If ABCD, I'm going to go ahead and draw myself that picture again. A, B, C, D is a parallelogram, and angle A is X, and angle D is 2x minus 3. Find the value of x. Now, if we look back up top, those are consecutive angles. They're next to each other. Consecutive angles are supplementary. So because they're supplementary, they must equal 180 when I add them together. I'm going to say x for angle A plus 2x minus 3 equals 180. Or 3x minus 3 equals 180. 3x is going to be 183, or x is going to be 61. So just like that, we took advantage of what we knew about our angles, and we were able to solve for x, find a missing value. Flip of the page, looking on to the next page, we're going to put some more pieces to use here. So right now, looking at example number 4, we've got a parallelogram. When they don't give you a picture, I suggest you draw one. We got X, Y, Z, W is a parallelogram with diagonals of XZ and YW. If XA, which must be the point in our middle, is 3 meters, so XA is 3 meters, and ZA is 5M, that's 3M, so this is 5M minus 4. We want to find M. Well, we know that XA and ZA are a diagonal that's been split by A, our midpoint, so I could say 3M equals 5M minus 4. Or I could say 2M equals 4, or 2 equals M. Looking at example number 5, we know that angles, in this case, this angle right here is 80. We've already talked about consecutive angles. 80 plus Z has to be 180. So Z must be 100 degrees. We've also talked about the fact that opposite angles are congruent. So 80 and X are the same. So that must be 80 degrees. Z and this angle not marked is the same. So we're going to mark that as 100. And then we're going to go back to our old rules where we know that a straight line makes 180 degrees. So I would say 180 minus 100 gives me 80, would have to equal y. Again, all we're doing is we're taking advantage of the rules that we've been given, and we're using them to our advantage. So, looking down at number 6, opposite angles are congruent. So I'm going to go ahead and mark them. Z must be 120 degrees. Now, because I know these are parallel lines, this diagonal and this parallel line and the same diagonal and the same set of parallel lines, I know that these must be alternate interior angles. So if this is 35, y must also be 35 degrees. So we now know z is 120 and y is 35. So 180 minus 155 would give me 25, which has to be my final angle in that triangle. So we'd say that x is 25 degrees. Looking over at example number 7. Example number 7, we know that, again, we're in the same boat with our parallel line and transversal, parallel line and transversal, transversal and parallel line. Tells me that x and 30 must be the same. So x must be 30 degrees. Now, I can also talk about 180 degrees on a line. I know this piece is 70. This piece must be 110. And then z and 110 are vertical angles. So z must also be 110 degrees. And finally, I'm going to look at it and say x is 30. Got 110, that's at 140. So 180 minus 140 would give me 40, which has to be the final angle in that triangle. So y equals 40. Notice how it is really important here that we've got our rules down, that a line is 180 degrees and that a triangle is 180 degrees, so that we're able to use our different pieces to our advantage. So, looking at the next problem here, we know that we've got 22 and we've got 2c. Well, we know that these lines are parallel and congruent because they are parallelograms. So 22 would equal 2c. Divide by 2, 11 must be c. Okay, pretty simple so far. We know that x to the midpoint is 15. Well, from the midpoint to the other side must also then be 15, which is a. Looking at b, they tell me that z, wx, this angle right here, is b. So we got to say that this angle w would be the same as this angle y, which is 31 and 18 put together, which is 49 degrees for b. And finally, the last piece of our puzzle here, they're asking for wxy. They're asking for wxy, which, to help you see, I'm going to mark in a different color here. Wxy is right there. Now I know that angle B right here and angle D right here, B plus D, has to be 180 degrees. Well, we've already said that B is 49 degrees. So the question is, what is D to make those consecutive angles supplementary? D would have to be 131 degrees. This has been Coach Eichner's Math. I appreciate you watching. And notice that everything that we're doing here, the magic number is 180. Hope you have a great rest of your day.